Hey everyone, welcome to my first video on this channel. Let's start with quick introduction. I'm Eugene and I'm from the GuidedMind AI. What is GuidedMind AI? The idea behind this startup is to build tools that will help to create reliable AI agents. Easy to say, but way harder to actually execute it, right? One of the most critical part of AI agents is how they remember things. That's exactly why our first product focused on RAG, Retrieval Augmented Generation. Alright, let's jump into today's topic, why RAG is essential for AI agents. In this video, I'm going to show you problems AI agents face without RAG and how Retrieval Augmented Generation actually helps to solve them. AI agents are built on large language models to find the right response. They have a context window that's basically the limit on how many tokens or words you can feed them at once. This context window is one of the biggest limitations with this technology. Most experts know that when you hit that context window limit, you get unexpected AI agent behavior. It starts to forget parts of the previous conversation, hallucinate, then the context is too large and confusing, and other weird things might happen. You can visualize it like a box with documents in it. More and more documents keep getting added even though the box is already full. And with each new document added, other documents get magically pushed out of the box. There are several ways to fix it, but RAG is one of the most efficient solutions. RAG lets you use dedicated vector database to scale that context window. This technology is about a new way to search data. We can call it semantic search. We call it semantic search, which is basically the same kind of search what LLMs use under the hood. First, let's run through a quick demo to show you this problem in action. We're going to walk through two different scenarios. One where the LLM hits its context window limit, and another where we use RAG instead of just blindly rely on LLM's context window. Let's see exactly what happens when we hit that limit versus RAG approach. By the way, I've set up a repo for this demo, and you can find the link in the description below. It's all ready to go, just click through and check it out. Let's say we built AI agent with a knowledge base, basically just one really long document. We are going to test two different scenarios here, so we can see UI split it onto two sections. On top, we have details about LLM service, what model we use, and what context limit we set. On the left, we have our AI agent chat with RAG. We need to provide RAG route, API key, and payload. Since GuidedMind is RAG as a service, we need to use API approach, and we don't need any SDK or configuration stuff. Instead, we'll use a beautiful UI wizard to set it up. I'll show you how in a bit. On the right side, we have our AI agent, which uses context as a part of prompt. Basically, we copy-paste a whole document into it. First, let's try a scenario with just context window. This scenario has two options. We need one with a large document. Let's select it. At the end of this document, we have the answer on our question. What's a secret code in Appendix Z? Let's try to find it. One moment. Here we go. That's Appendix Z and our access code in it. So let's click a tag with this question. What is secret access code mentioned in Appendix Z? Now, let's click Submit Query and see what will happen. This request might be problematic for two reasons. If the context is really large, 200k tokens or so, even powerful NVIDIA GPU like H100 will need noticeable time to process it. And second issue might be large context might have a lot of unrelated data, like in our case. And LLM itself will struggle to find the right answer. In our solution, it's First of all, a lot of unrelevant information, and context is big enough. And the LLM was not even informed, since it's bigger than our context window, what the right answer is and where it's located. So let's see what response is. Answer is part of our context, and in the end, it assumes something which is assistant and incorrect answer, but also mention that this question refers to the appendix Z, which is not included to our context. And that's actually a good explanation. Most advanced modern LLMs are properly trained and capable of identifying this. But even for them, it's not always easy, and that scenario need to be tested. In the worst case scenario, the answer will be strange or irrelevant, like in our case. Before we try the second scenario, right there, let me quickly show you our RAG as a service and demonstrate how to use it. All the settings have default values, which really helps to speed up the process, especially if you are not an expert in the field and not familiar with RAGs, and you don't know what those settings are. But if you are an expert, those defaults are a huge relief, since settings are document-based and you can quickly build advanced setup for your RAG. Okay, let's click dashboard, RAG, and create a new RAG project. First step, this page contains a form with simple project information, like project name, description, and category, and primary use case. For our scenario, we can call project name RAG with one large text document, and description can be RAG with one large text document for text doc for AI agent context window test. Here we go. For category, we can pick knowledge base, and primary use will be document search. Very simple. We can save project setup, and now ready to go to the next step. Step 2 is for uploading your documents and make individual configuration for each of them. You have options, browser files, upload from URL, or from your Google Drive. So let me pick one from files. I already have predefined large document. I can double check here that it's exactly the same document with also appendix Z in the end. Here we go, YZ. So this is our related to our question access code. And now I have options to config each document, so I can do it individually or all at once, clicking this review now button. So let's click on settings. For each document, we have pre-processing settings where we tell our RAG service how to format data based on specific file format. In our case, it's MD specific settings. Also, we have general settings as well. The metadata tab is for vector database configuration. Those kind of databases can save not just vectors, but also related metadata. But as engineers, we need to decide what metadata provides value for our use case and will be useful in the future. The next one is chunking. So here you can see different chunking strategy configuration. What's that? Basically, it's instructions how to split your document in database. So it might be many different scenarios how to do this, and to explain why, it's probably easiest explanation is to talk about table format. For table format, how do you want to split your documents on chunkings apart? You can do it by chunk size here, but you're not guaranteed that each row will be exactly this number of tokens. So that's why you might need strategy where you want to split it by row. And for table, it will be much better because if chunk will be row aware, it will guarantee that data will be searchable and useful for your search in AI agent. And the last block of settings is for embedding. We might use different embedding models and strategies to create our vectors. So it's important to pick the right one. This RAG service allows you to not just pick what's considered the best practice, but also experiment and find what will work best for your specific use case. So after a careful review of all those settings, we can save it and move to the next step. Processing. In this step, we started to create vectors for our database. Click Process Documents and wait. In our case, document is small and should process quick enough. After it was processed, we can see the updated status completed. If we click on the row to this extend button, we also will be able to validate results by checking the first chunk. You can preview chunk itself and see all metadata we saved in our database. Depending on your configuration from the previous step, it might be different chunk size, metadata, and embedding model. So you can see here pretty long text, but in the end we have chunk size, chunk number, chunk size, embedding configuration. All this information will be available for you. After validating our first chunk, we also can try to do vector search testing. Let me pick our search query, change similarity threshold, and click search. When we do this, in the result we can see not just relevant records, but also similarity score right there. When we're satisfied with results, we can move to the next step. Now we can set up RAG pipeline. Basically, at this step, we can tell RAG what output should look like. We might return a list of chunks as API output or process them using the LLM. Let me find these settings here to create a summary for our context. In our case, since we deal with simple scenario, point response will be good enough. Our simple AI agent should be capable to use such context to find right answer. Let's quickly go through these settings. First one is search method. In our case, we need vector search. And we also might change parameters for search itself. So I can skip it for now. And here also all default values should be good enough. Let's click Save. Again, we can test our RAG pipeline to make sure that pipeline settings works as expected. Since our setup is straightforward, I'm going to skip this step and click Next. Congrats, our RAG as a service is ready to use. In this page, you can find instructions how to use it. For now, we support REST API. On the top of that screen, you will get unique secret key right there for your RAG project. Below, you can find API route, which is API GuidedMind AI /RAG/search. Here, we've provided payload example for your request and expected response. You will need that to integrate with your AI agent. At the very bottom, you can click Test Endpoint and use your settings, so it's already headers and request body populated to test this API call. In our scenario, I will do it directly from my AI agent. Now we are ready to try this RAG version. Let me click cancel, copy my key, and here you can see again my RAG endpoint, API key, and only one thing, I need to use the same query. Here we go. Let's click submit query. Again, you will find this small AI agent in description below. I will provide a GitHub link. And here you can see exact answer we expected from our AI agent, which is this access code. So we clearly see that same LLM model now work with large documents, and context window is not longer a limitation. Also, we cannot see it in our test, but LLM performance should be improved too, since we are not polluted our query with long and potentially irrelevant context. There you have it. In just a few steps, we've created RAG and enhanced your AI agent with it. If you have any questions or want to start using our RAG system but need some help, feel free to contact us. And thanks for watching.